Right, good. Okay. Hello, you're right. This is a quick video to go with the work that you've been set by Miss Kitchen to do over the summer about an investigation into hot chocolate and the effect on the temperature of the hot chocolate of putting marshmallows in your drink has. All right. Now, this you've been given hopefully in a pack. Well, I think you've had it emailed actually on the Sims app. You've had it sent. You've had some work sent. It should look a little bit like this. Okay, so it's a sheet for you to fill in. It's an investigation for you to fill in, and Miss has given you some structure to this to help you do it. Okay, so this can be printed off and copied down, or you can copy it out on your own paper. But this is to be done and brought back with you in September, so we can see your work. Now, the idea with this investigation is that this is keeping you thinking about the scientific process and how science works, and switched on to science through the summer, because obviously we've had a bit of time off with the stuff with coronavirus, etc., where we've been working from home, but that's been very hard to do practical. So this idea is that you can do this practical. Now, along with this, Miss has given you a PowerPoint, which looks like this, where it doesn't look exactly like this because I've changed the front to show it as a hot chocolate investigation. But you should have had this PowerPoint sent to you as part of the app as well. Okay, so this PowerPoint is really important because it talks you through it. So lots of things I'm going to say are going to be on this PowerPoint for you. And it also gives you some results. So this slide here that you should be looking at now gives you some results. If the main thing that some of you might not have is a thermometer to measure the temperature of the drink. Some of you might have a thermometer in a first aid kit or as part of cooking equipment. You can buy thermometers really cheaply at Boots or other chemists. But if you don't have a thermometer or you don't have a way of doing this practical, you can still do this work by using these results here. Okay, so if you can't do what we're going to talk about yourself, so ideally you do it yourself if you can't use these results here. Okay, so what's this all about? Well, it's all about basically hot chocolate. So you need some hot chocolate. There I've got the old classic Bourneville, which bit of sugar and bit of milk, that makes a nice hot chocolate. Okay, so you're gonna make hot chocolate, all right, and you're gonna need some marshmallows, all right, because what we are investigating is the effect of using marshmallows on the temperature of your hot chocolate drink over time. Okay, so the first thing you're going to have to do, if we share this again, no. Let's go to the top of our PowerPoint. Investigation is about, do the marshmallows keep the hot chocolate warmer? All right. So our hypothesis is using marshmallows affects the temperature of the drink, and we're predicting. Well, this is saying, does it keep it warmer? Okay. Do we think it's going to keep it warmer? Do we think it's going to be colder? That would be our prediction. And the way we're going to go about this is we're going to make two drinks, aren't we? And we're going to have one with marshmallows in and one without. So the independent variable is going to be whether or not we have the marshmallows in. Okay. And the dependent variable is going to be the temperature. And that's the one that you might struggle with recording at home, but you can easily get a thermometer from a chemist's or use the results that are further down. Now, here would be a method, because obviously we need to keep certain control variables the same. When we make our two different hot chocolates, one with marshmallows, one without, everything about those hot chocolates needs to be the same. Otherwise, that might be changing it. We can't have two different temperatures because that might be changing it. We can't have two different volume, amounts of hot chocolate, thickness of the hot chocolate, all that we need to keep controlled. Okay, so this method will help you a little bit to do that, and it will also give you something to write in the method sheet of what you're going to do. Yours might be slightly different. Okay, right. We're going to make a prediction. Here are some results. Now, you've got a results table like this on the sheet that Miss Kitchen's sent to you. So this is where you're going to put your method in your own words. So the method on the PowerPoint I showed you, you'd need to reword that into your own words to go here. How are you going to do it? Exactly step by step. So me or Miss Kitchen could follow your instructions and do it exactly. it's important in your method that you say exactly what you're controlling. So like, we're going to have the same amount of hot chocolate because I'm going to make it 200 ml or whatever it might be. Okay. Okay, so that's basically your method. Independent and dependent variables and things you're going to control. Well, again, we've talked about that in the PowerPoint. Your prediction goes here. So do you think it's going to stay hotter, or do you think with marshmallows, or do you think it's going to cool quicker with the marshmallows in? Try and give some reasoning as well. And then this, when you do your experiment, okay, get your hot chocolates, starting temperature, record the starting temperatures, okay, and then every 30 seconds, take the temperature of your 2 hot chocolates and record them with the marshmallows. What's the temperature? Without the marshmallows. And one will stay hotter than the other, we imagine, okay. And here, this idea, change in temperature. So what did it start at? Take away what it ended at, and that shows you how much it's cooled down, okay. Is it going to cool down more with marshmallows in or not? That's our investigation. To get a good answer, we've got to control everything else apart from the marshmallows or not. But that's where you put your results. If you can't do this practical, use the results off the PowerPoint. Okay, good. Right. Explanation. What does your data show you? You need to get your data and you need to draw a graph. Okay, so the graph, and again, there's some help here in the PowerPoint. What kind of graph are you going to do? Okay. Is it going to be a bar chart? Is it going to be a scatter graph? Is it going to be a line graph? Okay. Do we have 2 sets of data, okay, that are continuous, i.e. numbers, or do we have like a category like marshmallows, no marshmallows? Because if you've got categories, marshmallows, no marshmallows, you want to be drawing a bar chart, okay, because it's going to be bar chart, or are we going to say time, temperature? Okay, in which case we would look at a line graph. All right, so think about it. Are we going to do a bar chart, marshmallows, no marshmallows, and plot the change in temperature? Or are we going to do the time on the x-axis against the temperature on the y-axis, and then we'd have to draw 2 lines? Okay, so quite a few things to think about there. Okay, you decide, see what you can come up with. Make sure you use a ruler and a pencil to draw your graph. Okay, good. Right, here we are. So back to this sheet. Once you've got your results, okay, you've set your experiment, you've done your experiment, you've got your results, you can draw your graph, and then you can look at making your conclusions. Okay, so did having the marshmallows keep the hot chocolate warmer, or did using the marshmallows make it cool down faster? Okay, that's, and then the extension down here, why? If it stayed hotter, why do you think that? If it got colder, why do you think that? And this is about heat transfer, insulation. So did some of the energy in the hot chocolate, was it transferred to the marshmallows so that the hot chocolate cooled down? Or did the marshmallows insulate the top of the chocolate, stopping the radiation of the heat energy from the top of the drink to the surroundings? You know, lots of different things to think about. Okay, good. All right, that's just a quick video to help you on the way with this practical. Get it done, get the sheet done over the summer. Bring it with you when you come back in September, and we can see what you've done, and we can have a discussion about how it was a valid test, whether you controlled all the controls, what were the issues with the practical, and yeah, take it from there. Right, 10 minutes, quick video. Good luck with it all, folks. I'll stop this recording.